right, people, welcome back. So let's go over the previous video. We went over bonding capacity. So again, if you have 7 valence electrons, you make one bond. If you have 6 valence electrons, you make two covalent bonds. 5 valence electrons, you make three covalent bonds, and 4 valence electrons, you make four covalent bonds. Always adding up to 8. Octet rule. Okay, so if we notice here, this Mickey Mouse looking molecule, which is water, two H's, H2O. Oxygen has 6 valence electrons, so it forms two bonds. Here we have nitrogen. This is actually ammonia. Some of you might know it's a common cleaning product. Ammonia has nitrogen and 3 hydrogens, NH3. So nitrogen has 5 valence electrons. And let me make that red. So it makes 3 bonds. 1, 2, 3. Carbon has 4 valence electrons, so it makes 4 bonds. Okay? So here, let me see if I can move myself. There we go. Carbon has 4 valence electrons, and this diagram shows how each carbon forms 4 bonds, right? It forms 4 bonds, 1 bond with another carbon, and then 3 bonds with different hydrogens. Okay, so there's a sharing of 2 electrons here with this carbon, a sharing of 2 electrons here with that hydrogen, 2 here, and 2 here. If you add them all up, adds up to 8 for this carbon. Same thing here for this carbon. So let's, if we label them. Okay, carbon 1 and carbon 2. I could write it better too than that. All right, there. So we have 1, 2, 3, 4, 5, 6, 7, and 8 for that carbon, for carbon 1, and then 1, 2, 3, 4, 5, 6, 7, 8 for carbon 2. So the octet rule is satisfied. So types of covalent bonds. So far we've only seen single bonds, right? Two electrons. Sharing 2 electrons is a single bond, one shared pair of electrons. This is also the weakest type of bond, weakest type of covalent bond. A double covalent bond, can you guess how many electrons are shared? If you guess 2, you're right. You are right. So it has 4 electrons. Actually, let me not confuse you. 2 shared pairs of electrons. All right. So 4 total. 2 pairs. Okay. 2 and 2 make 4. And we can see this here in this double bond for oxygen. So each line, that line there, each line represents, let me show you, each line here represents 2 electrons. Okay, so there's 2 lines for oxygen. Oh, excuse me. There's 2 lines for oxygen. Right there, you can see it. There's 4 electrons. Here we have nitrogen with 3 lines. Okay, so just count each line count by 2, and that's how many electrons there are. So for a triple bond, a covalent bond, it has 3 shared pairs of electrons. So 6 total. Right? If I put here. 4, put it in parentheses. 4 total. Let me bring down the font a bit. There we go. And 6 total. So it's like counting by 2s. It's like counting by 2s. And with the first one, we have 2 total. Okay. Now let's make some molecules. So all you have to do on this slide is grab this hydrogen, grab an electron. Okay, grab this hydrogen, then grab another electron. And sometimes it's a little wonky, so just be patient. You have to grab it where you see the cross. There you go. Fits right there. Okay, there you go. So make sure just they're all touching because you remember they're sharing these electrons. So what type of bond is this? How many electrons are being shared? I see two electrons being shared, one from each hydrogen. So it's a single bond. Right? What about nitrogen? We have two nitrogens. The formula here is N2. That's all we have to work with. We can't grab any of these. So grab a nitrogen and an electron. Electron disappearing, so let me grab another one. That's disappearing. Grab this electron. They're all disappearing for some reason. Okay. What about grab one of these? Oh, that didn't disappear. Good. That one's there. Grab another one. And grab another one. No one disappears. You can just right click and copy, and it should make a copy right on top of it. Oh, nope. Got to say paste. There you go. Okay. So nitrogen, how about we just put the valence electrons first? So we know nitrogen has 6. No, it has 5. Let me do paste again and get another electron. Because these are disappearing for some reason. So all I did was just right click, copy, and then I'm just control V to paste in. So we need 5. So nitrogen has 5 valence electrons. That means it can make, let me put some here too. Okay. All I did there was just do Control V a bunch of times to paste those electrons because the other ones are disappearing. We're going to forget about those up top for right now. All right, so we should have 5 valence electrons. Okay, so how many bonds can it make? Well, if we go back here, 5 valence electrons, we need 3 covalent bonds. Okay, we need 3 covalent bonds, 2 valence electrons, or 6 valence electrons, 2 covalent bonds, and 4 valence electrons. 4 covalent bonds. All right. Hydrogen was the exception because hydrogen only has 1 valence electron. So let's pair some electrons up here. Okay. So I'm just taking them from the nitrogen from each one and just pairing them up, just so they kind of kiss like that, kind of touch. And let's. So I need 3 bonds, right? So I made one here, another one here, and let's make one more. Okay. So we should have. Oh, did I mess up? Did I have too many electrons or did I have not enough? Oh, maybe one is hiding here? Nope. I need one more electron here. Nope. Control Z and then Control V. There we go. Okay, so I should have a total of 8 in each one. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, and 8. So this one can go away. So these two left here, these are called lone pairs that are left over there. Those are called lone pairs. All right, so these nitrogens, they're sharing these that are in the middle that are touching, and sorry, these are not touching here. Let me move this one up a little. Let's kind of squish them together. That's perfectly fine. And just kind of make sure they're touching, kind of like that. All right, so there's nitrogen. Oxygen has, that's N2. Oxygen, we're going to make the molecule O2. And this one disappears. And I still have this one I copied over here that I know works. So I'm going to put my cursor on this and just control Z. Maybe I need to grab one. Okay, let's see. How does this work? Boom, fine. So I'm just going to copy this because I know this electron doesn't disappear. And I'm just going to kind of control V and paste it a bunch of times until I have 6 total because I know oxygen has 6. I messed up. Make sure that's highlighted when you grab it. I know oxygen has 6 valence electrons. I keep grabbing the background. That might happen to you. Please don't get frustrated. It's happening to me. See, I just did it again. Just try your best on this, okay? All right, so that oxygen has 6. Let's bring in our other oxygen. And then just Control V to get those electrons. We need 6. Is that 6? Yeah. And you make sure your electron is highlighted when you grab it and when you move it, or else you're going to be moving in the background. Okay, there we go. All right, so we have 6. So we need how many? 6 valence electrons. We need 2 covalent bonds. We need 2 covalent bonds. Okay, so let's see. We need to share them in the middle. There's one right there. Again, I'm grabbing the background. Let me grab the electron. Move it out a little more. There we go. So they're sharing. Let me separate this one a little more so it looks a little neater. Okay. So they're sharing, those 2 oxygens are sharing those in the middle. There are 2 lone pairs on each oxygen. So there's 1 lone pair here, 1 lone pair here on that oxygen. And on this oxygen, there's 1 lone pair here and 1 lone pair here. So when I'm talking about these lone pairs, I'm talking about the oxygen, the electrons, the pair of electrons on this oxygen that's kind of hanging out by itself. Okay, so that's 1 lone pair, and that's another lone pair. All right. Okay, let's do the next one. All right, NH3. These are a little easier because they're single bonds. How do you know they're single bonds? I don't know. Maybe I guessed. Let's find out. So I need to put 5 valence electrons around this nitrogen. Okay, and hydrogen carries 1 valence electron. And I know if I have 5 valence electrons, then I can make 3 total covalent bonds. And I have 3 hydrogens. So I'm going to line these up, and these hydrogens bring an electron with them. So I'm going to line them up near an electron and just bring its. I'm going to line the hydrogen up near an electron from nitrogen, and then I'm going to bring the electron from hydrogen over. Okay, there's another one. And last one. And here we have these 2 lone pairs, or 1 lone pair, sorry, hanging out at the top. All right, so this is what your, I forgot this part here. So what type of bond is this? I see 1, 2, 3, 4, 5, 6, or 2, 4, 1, 2, 3 covalent bonds. Okay, so if you see 3 covalent bonds, that's a triple bond. And that's covalent bonds with the same atom. The same atom. See, there's 2 covalent bonds here. The same atom. This oxygen is sharing with this oxygen. So that's a double bond. All right, and if we go here, how many? I see just 1 pair being shared here, 1 pair being shared here, and 1 pair being shared here. That's a single bond. All right, now what about water? Let's make some water. Oxygen again has 6 valence electrons. Okay. 2, 3, 5, and 6. Okay. Now I have a hydrogen that comes over. Okay, how do you know how many, oh, excuse me. How do you know how many bonds you're going to make? Well, 6 valence electrons. There's going to be 2 covalent bonds. Okay, 2 covalent bonds. So let's make one right here. Actually, let's make it down here. Okay, and then let's put one here, and another up here, and then another one over here, and then hydrogen comes here, Then bring its electron with it. So make sure kind of touching, and there you go. So how many bonds, or what type of bond do we make? There's only one pair of electrons being shared between these two atoms, and then one pair of electrons being shared between these two atoms. So that's again a single bond. If it was more than one pair being shared between the same atom, then it would be a double bond or a triple bond, and we'll see that right here with carbon dioxide. So, all right, you might be wondering, how do I know which one goes in the middle? How do you know which one goes in the middle? Well, which one can make more bonds? Can oxygen make more bonds, or can carbon make more bonds? Well, let's find out. How many valence electrons does carbon have? 4. How many does oxygen have? 2. So, I'm sorry, how many does carbon have? 4, yes. Oxygen has 6 valence electrons, so it can make, oxygen can only make 2 bonds. Okay, so carbon can make more, so the atom that can make more bonds goes in the middle. That's called the central atom. And it's all these electrons over here. Carbon has 4 valence electrons. Okay. And oxygen has 6 valence electrons. I'm just loading up the electrons. Okay, I'm just going to disperse them around. Not necessarily even or anything yet because we haven't made our bonds. So 2, 4, 6. We're good there. And this oxygen has 2, 1, or that's 2. 2, 4, 5, and 6. Okay, so let's make some bonds. All right, so carbon wants to make 4 bonds, but there's only 2 other atoms. So let's bond carbon twice. Let me label it. Let's bond carbon twice to oxygen 1, and let's bond carbon twice to oxygen 2. Okay, and let's see if it works. So there's one bond here and another bond here. There we go. The rest of these, let's kind of pair these up. You can move these around freely. It's okay. Just kind of pair them up. Those again are lone pairs. Those are lone pairs. They're just hanging out with each other. All right, let's do the same thing on oxygen 2. All right, so pair, let's bring this one down here and this one over here. Kind of touch them so they're sharing that one. And let's have them share this one too. It's kind of difficult. Let me bring this one over a little more. Bring the oxygen over so it looks a little nicer. Okay, there we go. More or less, you get the point, right? And then we got the other 2 lone pairs on this oxygen. So, what type of bond do we make? Okay, you might be thinking, hey, oh, there's 4 bonds. 1, 2, 3, 4 bonds, and it's both to oxygen, so it's a quadruple bond. No. Okay, there's 2 different oxygens, oxygen 1 and oxygen 2. Okay, and I erased the 1. Oxygen 1 and oxygen 2. So how many does it make to oxygen 1? How many bonds? 1, 2 bonds to oxygen 1. How many to oxygen 2? 1 bond. Oh, can I keep moving it? And then 2 bonds. So how many, what type of bond? What's the highest number of bonds made? 2. Okay, so this is a double bond. All right. What about methane, CH4? Let's make some methane. Again, carbon has 4 valence electrons. Just making them right there. And then we have 4 valence electrons. We have 4 hydrogens. Nice little sequence going on here, okay? All right. Now I'm just going to pair these up a little better. There we go. Okay. So what type of bond do we make? Well, sharing a pair of electrons to each hydrogen. And again, these are different hydrogens. So one, two, three, four different hydrogens. So this is going to be a single bond. Can't write yet. It's a single bond, right? You might be thinking, oh, it's a quadruple bond again because it's four bonds and they're all hydrogens, right? So they're the same. It's a quadruple bond. No. Okay. It's only sharing one electron to each hydrogen, and that other hydrogen is sharing one electron back. Okay, so pair of electrons here, 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 and here. Okay, so I know this video is a little longer, but the when we produce these molecules, it's important to know distinguish the difference between a triple bond, a single bond, and a double bond. And it can get confusing when we're using diatomic molecules, and these are examples of diatomic molecules.